Do you feel the vibes?
We are moving on to section 4.3 today. In the last lesson, we learned about how to find zeros, how to estimate zeros from a graph, actually, right? And today, we're gonna kind of, go deeper into that. So, last time we talked about roots, right? Remember we said if a parabola crosses the x-axis here and here, right? So let's say if this is x equals 2 and this is x equals 4, x equals 2 and x equals 4 are solutions to this, right? And or they're the x-intercepts. And if we have the equation, then 2 and 4 are also called the roots of the equation. Okay? Now, if two numbers are roots of a quadratic equation, right? If P and Q are roots, then you can say x minus P, x minus Q is equal to 0. So for example, if 2 and 4 are roots, then I can say the equation is x minus 2, x minus 4 is equal to 0. For the one I drew, yeah.
Okay, so that's the equation.
Right. Well, yes and no. So it's not the equation, but these are just roots, okay? Because there could be a different value of a in the front, okay? All right, so if you have the two roots, you can multiply the two binomials and you can write the equation in standard form, but making sure that a, b, and c are all integers. So why don't we write a quadratic equation with the given roots here? So we're going to say f of x is equal to x plus 2, x minus 7. F of x is equal to, and then you multiply these out, right? So you get x squared minus 5x minus 14. Okay? All right. Now, actually, the way I'm going to do them, instead of saying f of x equals, right? If it's asked for, if I'm asked for an equation, instead of saying f of x equals, what I can also do is say x plus 2, x minus 7 is equal to 0. This way is actually better if you have a fraction. So take a look here. Here I have 1/3 and 6, right? So it'll be x minus 1/3. X minus 6 is equal to 0. But remember, a, b, and c have to be integers, right? So I have to get rid of this fraction somehow. What I do is I have to multiply by 3 on both sides. When you do that, when you multiply something by a number, you only distribute it to one of the parentheses. If you distribute it to 2, that means you divide it by 3. That means you're multiplying it by 3 times 3, 9. So you only distribute it to 1. So you get 3x minus 1 times x minus 6 is equal to 0. So now let's see, we get 3x squared minus 18x minus x plus 6 equals 0. 3x squared minus 19x plus 6 equals 0. Right? That's it. No, because you want it, because it says to write it in standard form. This is standard form. Okay? No fraction. Okay. So now this takes us to something very, very important. What this takes us to is the zero product property, right? The zero product property says if A times B is equal to 0, then either A has to be 0 or B has to be 0 or both have to equal 0. Which means it's exactly what you've been doing your whole life, right? Like if you have something like this, you know, x minus 2, x minus 1 equal to 0. How do you solve this? You set each one of them equal to 0 on their own, right? And you solve it, right? You say x minus 2 equals 0, x minus 1 equals 0. The only reason why we can do that is because you have something times another thing equal to 0. If this wasn't a 0, if it was another number, you could not do that. So this is the zero product property. Okay, let's talk about factoring, everybody's favorite. Okay, so to factor trinomials, the first thing you have to look at is, can you factor out a GCF, right? Is there a greatest common factor that you can factor out? Next, you can factor the trinomial, like Hannah was saying before, right? 2 parentheses, okay? And remember, there are some special cases, okay? The special cases are this. A perfect square trinomial. So how do you get a perfect square trinomial? The first one and the last one have to be perfect squares, okay? And then this one has to be 2 times A times B. And then you can factor it like this, A plus B quantity squared, all right? Or if there is a minus here, then this becomes a minus. And then the other one is a difference of 2 squares. Now you have perfect square, minus in the middle. That's when you can factor it, A plus B, A minus B, like this. All right? I think these are all things you learned in Algebra 1. So in Algebra 2, we don't like learn these from scratch. Okay? Yeah. Huh?
How come, like, isn't it no C at all?
Well, the C is no, like it's the C is the B squared, right? So it's like a perfect square. Okay, so take a look here. We can definitely factor out a GCF. We can factor out a 4x, and I get x plus 4 is equal to 0. And now you have one thing times another thing equal to 0. So we say 4x equals 0. X plus 4 equal to 0. So here x is 0, x is negative 4, and I have 2 answers here. All right, here. I can factor out a 5x, and I get 4x plus 3. 5x equals 0. 4x plus 3 equals 0. X is 0. X is negative 3 over 4. Right? Okay. Next one. Okay, there is not a GCF that I can factor. But now I'm like, okay, first check, is this a special case? If not, then you can factor the other way. So let's see. Okay, this is a perfect square. This is a perfect square. So maybe we can factor like this. X plus 4 squared equal to 0, right? So what you do is you take the square root of the first one. You take the square root of the last one. But now you have to check, right? The middle number has to be this times this. What do we have so far? Times this number. Times, what do we have? 8x. Is this 8x? It is. So yes, I can factor like this. Okay? Now, you can actually take a square root of both of these. So x plus 4 is equal to 0. X equals negative 4. Okay? Let me do a few more and I'll take questions. Okay, take a look at this one. Perfect square. Perfect square. Now there is no GCF to factor, right? I already checked. Perfect square, perfect square. So let's see. Can I factor like this? Let's see. So it'll be the square root of the first one, which is how much? And then the square root of the last one, 9, 3. Okay, since there is a minus here, I put a minus here. And now let's check. 2x times negative 3. How much is that? Negative 6x times 2. Negative 12x. And yep, that's negative 12x. So that equals 0. 2x minus 3 equals 0. 2x equals 3. X equals 3 over 2. Now look, you have to go that extra step and check, right? Because if instead of this, if it was, let's say, 4x squared minus 14x plus 3, plus 9, right? Okay, you're like, oh, perfect square. Oh my God, that's lovely. I could just do this. Okay, but does this work? So look, so 2x times negative 3, what is that? Negative 6x times 2. No, when you're checking, it's 2ab. So you do times 2. So negative 12x. And you see that doesn't equal this. So, yes, there's perfect squares on either end, but you can't factor this way. Okay, any questions before I move on? Yeah.
If we forget to identify this perfect square, can we still do normal factoring and still get the answer, but it'll be slow?
It'll be slower, but then you might get like x plus 4, but you still have to write that again as x plus 4 squared, because you have, especially in honors, you have to recognize the special case. All right? Yeah. So in that level, I might be okay, but in honors, I want you guys to recognize the special cases. Okay, take a look at this one. I know you guys can solve this by taking a square root of both sides. However, the instructions say to factor and solve. So first, I need to see that you factored this, which means first you bring the 36 over to this side, set it equal to 0. Now, this is difference of two squares. So this will factor as 2 parentheses. Take the square root of the first one, xx. Take the square root of the last one, 6, minus plus. And so now, x minus 6 equals 0. X plus 6 equals 0. X equals 6. X equals negative 6. And we're done. Okay, this one. I factor out a what? 9x. And I get 9x minus 1 equal to 0. So here, 9x equals 0. So x is 0, and then 9x minus 1 equals 0. X is 1 over 9. Okay, the next one. The next one is a trinomial. It does not have a GCF to factor out. And then, does it follow a special case? No, because it's not a perfect square in the first and the last. Okay, so I factor this, right? I'm going to get, I need two numbers, xx, two numbers to multiply to negative 15 and add to negative 2. So what do you guys think? Negative 5 and positive 3. So x minus 5 equals 0. X plus 3 equals 0. X equals 5 and negative 3. Okay. This one. We want to bring the 11x over. Now, I need two numbers that multiply to 30 and add to negative 11. Right. So if you get, stumped, right, go in order. So how do we get 30? I like to go like systematically, right? 1 and 30. But now look. If they have to multiply to positive and add to a negative, that means both of these have to be negative, right? So -1 and -30. Okay, that doesn't add to 11. And then the next one is 2 and 15. And then the next one is 3 and 10. And then 5 and 6. So of those, it's the -5 and the -6, right? So that's how you can do it. Go in order, otherwise you're just like, don't go randomly, right? Don't choose just random numbers. So it'll be x minus 5, x minus 6. And then here, x equals 5, x equals 6. Okay, take a look at this one. No GCF to factor out. All right, this time I have a 5 here. Okay, so this is going to be 5x and x. Now, with foiling, we need to make this a 34. So let's take a look. You have the 24 here, right? And notice it's plus plus, so everything has to be a positive. So what are some ways we get 24? 1 and 24. Yeah. Like first, outer, inner, last, when you multiply the binomials. So it's like, so look, when you're multiplying out these two, right? You know how like first you do x times x and then x times x. So x times x, these are the first terms of each. And then x times -6 is the outer term. So it'll be FO, right? So it's first, outer, inner, last. So the first terms are x and x, and then the outer terms are x and -6. And then the inner terms are these. That's it. Yeah, and then the last terms are these. I know. I have to say FOIL is actually not my favorite. Because it only works for like binomials. But anyways. Okay, so let's continue. So how else can we get 24? 3 and 8. 4 and 6. Okay, so what you have to do now, right, is plug one of these in here and make sure we're going to get 34 in the middle, right? So let's say if we did the +1 and the +24, right, will that work? Here we get 120, so that doesn't work. So which one works? Well, you trial and error. Let's see 4 and 6. Does this work? 30 and 4. Oh my gosh, this totally works. This is it. Yay, we did it. Okay, trial and error. So, Well, if you multiply 4 and 6, it's 24. But it has to be 5 times 6, that's 30. 4x, right? This is 30x and 4x. That'll be 34x. Okay? Okay. So now, x is -4/5. X is -6. Okay. Let's do one more. All right. So here we go. Now this one you have a 15 here, right? So we have some options. It's either going to be 5 and 3 or 15 and 1, right? So how do you know which one? So let me tell you, if these other numbers are all small, chances are you're going to go with the smaller numbers, right? So why don't we try 5x and 3x? Now, there's only one way to multiply to a 1, so that's 1, 1. And you notice how it's minus plus? That means it's always going to be minus minus. So now let's see if this works. -5x, -3x, that's -8x. This does work. So this will be x equals 1/5, x equals 1/3. Okay. So let's do some of these word problems. The height of a javelin in feet is modeled by h of t, and this is the equation, where t is the time in seconds after the javelin is thrown. Okay. So we have height in feet and t in seconds. How long is it in the air, right? How long is it in the air? That means basically when does it hit the ground, okay? So if it's like this, right? It is thrown at t equals 0, and then it goes up in the air, and then at t equals, at some point, it goes back to the ground, right? If I find what the time was here, then I know how long it was in the air. Does that make sense? Yeah. Yeah, it would start at 5. You're right. Good. Good. Yay. Okay. So, yeah. Okay. So now, let's see. So what we're going to do is h of t is equal to 0. So negative 16t squared plus 79t plus 5 is equal to 0. Now, guess what? We need to factor this. Okay? So first, I hate having a negative in my a. So I'm going to divide everything by a negative, which means this is going to be 16t squared minus 79t minus 5 is equal to 0. Okay? Questions? Okay, now let me show you another way to factor this. Okay? Because look, when we factor this, it's either going to be like 1 and 16 or 4 and 4 or 2 and 8, right? Too many choices. So let me show you a different way to factor this. It's a shortcut. What you do is you take this first number, the 16, you multiply it to the negative 5. So now I get t squared minus 79t minus 80 equal to 0. We're doing this temporarily. Now, let's factor this. We can factor this, right? How can we factor what two numbers add to negative 79 but multiply to 80? So t minus 80, t minus 1. Is that right? Plus 1. But now, remember how I took out the 16? I was not allowed to do that. So now I got to bring the 16 back.
Wait, isn't it plus 79t, not minus 79t?
No, because we multiply it through by a negative.
Oh.
So now, remember how I took out the 16? That was illegal. I put the 16 back. Now, though, I have to go through and simplify. So look, this one, they can both be divided by 16, so I need to do that. That means I get t minus 5. This one you can't simplify, so it stays. So finally I get t equals 5. T equals negative 1 over 16. Okay, so the t equals negative 1 over 16, I need to throw it away because you can't have negative time.
Wait, why did I think it was 0?
Ugh, t equals 5, sorry. Yes. So now t equals 5, right? So that means the second time it hits is at t equals 5, right? So it was in the air 5 seconds.
What we usually get a second after that.
So it's not like you kind of have to take it as they come, right? Because this is the thing with word problems. Okay, you know this thing that I showed you, this different way of, this other way of factoring, the shortcut? why don't we apply that to this one here, I. Okay, so let me write the problem down again. 5x squared plus 34x plus 24 is equal to 0. And okay, so I'll do it again, and then I'll tell you what my reservations are about this. Okay, so you basically take the first number and you multiply it to this. So now I get x squared plus 34x plus, what is it? 120. Is that right? Huh?
That's that we want to just do.
I'll go back to the last one in a minute.
I've been doing it.
Okay. Okay, let me do this. Okay. So now, all right. So now I'm gonna factor this. Okay. Okay. So x and x. Now I need two numbers that multiply to 120, but add to 34. So that's actually 4 and 30, right? So plus 30 plus 4. But now, remember how we had taken out the 5? Bring it back. Okay? Lastly, you have to simplify. So this, the 5 and the 30 can both be divided by 5. So you divide it by 5. You get x plus 6. 5x plus 4 is equal to 0. So notice we got the same thing as before. Okay, so this is actually my least favorite way of doing it. The reason is,
So good.
Of course.
anyhow. Okay, so let's take a look at this next one. The length of a rectangle is 2 feet more than its width. Find the dimensions of the rectangle if its area is 63 square feet. For these, I always start with a diagram. And I get it. Sometimes some of you, might just be able to go to an equation from this. I get it. Perfect. Great. Good for you. However, starting off with a diagram is really a good habit to form because things are going to get more and more complicated, right? And you want to get into that habit because by the time you get to calculus, these things are not going to be as straightforward. And so you really want to get into the habit of problem solving skills, right? So sometimes the reason why we have these word problems is not so we can find out what X is. Again, nobody cares about the answer. We're teaching you the skills, right? They're just for you to learn the skills. So we go ahead and draw a rectangle here. And, okay, the length of the rectangle is 2 feet more than its width. So suppose the width is X. The length is X plus 2. We are told that its area is 63 square feet. When you're given a quantity like that, whatever quantity you are given, that's the formula with which you start. So we know that area is length times width, okay? We also know that the area is 63, and that's equal to X times X plus 2. So now, can I just say X is 63 and X plus 2 is equal to 63? No, because it has to be zero product property, right? If they're not equal to 0, I can't do that. Which means I got to bring everything to the same side and set it equal to 0. So distribute this. 63 is equal to X squared minus 2X. So X squared minus 2X minus 63 is equal to 0. Now I need to factor. So I'm feeling like negative 9 plus 7. What do you think? There you go. Oh no. This should be a plus. So then it's plus 9 minus 7. Okay, so now X equals negative 9, X equals positive 7. Okay, when you go back, Because x is physically the length of one of the sides, it can't be negative. So then x equals 7. That means the width is 7 feet, the length is 9 feet. Okay? All right, so we can stop right there.
Press start.